I want to talk now about, earlier on I was talking about my day job, which is cloud and big data and new platforms. I want to come all the way down to the other end of the scale now, which is the Internet of Things. And now, I'm sure you were in Darrek's brilliant keynote earlier where he was showing off his Nodecopter. This is usually the point where I pull out an array of Raspberry Pis and Arduinos and gadgets, but I don't actually have any with me today. So I'm afraid if you came looking and excited about gadgets, I don't have them with me today, although I have plenty somewhere in a box. I've just moved house, so they're all in a box somewhere. So my day job is working on this thing called Cloud Foundry. I spoke about that earlier. But I'm also into all kinds of other spaces. In particular, I like making stuff and trying out little electronic things because it kind of takes me back to when I was growing up in the 80s and I had an 8-bit computer that I could take the lid off and understand. And my goodness, I could solder things onto the motherboard myself. I wouldn't dare to do that with a shiny device like this. And as it says on the slide, I'm very excited by the Internet of Things. I'm a member of a couple of communities, one of them being the London IoT community, which has monthly meetups that are always massively oversubscribed, which I think says a lot for the interest in this space. And I'm also a member of the Eclipse machine-to-machine community, the industry working group we have there. So contact details there, additional contact details here. I am both Andy Piper, and I am also mqtt.org on Twitter. So if you need to contact me or ask me about any of these things, please do so. So first of all, I want to talk about what the heck this Paho thing is. It's in my, my title of my presentation. What do we mean by M2M, Internet of Things? And what is this MQTT thing? It's probably going to be about the first half an hour of the talk, I imagine. And then we'll go on and look at what the Java story is. It's a little bit unusual for me because normally I'm Mr. Polyglot and I stand up here and talk about scripting and all kinds of non-Java languages when I talk about MQTT. I have to keep checking myself. I'm on my MQTT gig now. I'm not on the other one. Stop! Don't say that cloud word. So I really want to dive into what's happening in the Java space, particularly around Internet of Things and the Eclipse space in particular. So first of all, we have this Eclipse project called Paho, and when I was first getting involved, and when IBM, long story, I'll talk about it in a moment, but IBM donated this thing to Eclipse, and they said they were going to have this project called Paho, I thought, what the heck is that? And it turns out that Paho is a Maori word meaning to broadcast or to tell lots of people. And the idea with the Paho project at Eclipse is to be a home for protocols which enable us to really spread out information and transmit data. These are emerging areas, so although they've actually been around for a long time, this is still quite a new space. So when I talk about MQTT, I often get a lot of people saying, "We've never heard of it." So there's usually some explaining to do. Taking a step back then from what this Paho thing is and means, the Internet of Things. Well, Darrek spoke about it earlier and put me on the spot and asked me to define it, which was a little unfair. I didn't have my best hat on at the time, and I didn't really come up with anything particularly brilliant. But it's this idea that increasingly we're instrumenting our world and we're instrumenting ourselves. I've got one of these little pedometer trackers, smaller than the size of a USB key. It's got Bluetooth. It can keep me up to date with how much I'm walking and climbing, and it can monitor my sleep and all those other kind of things. And we've got these little devices now that have enough processing power just to do those kind of tasks. And as we network them and put that information together, we can start to do some much more interesting things. So I spent 10 years at IBM before I joined VMware and now Pivotal. And IBM over the last few years have been talking about this concept they have called Smarter Planet. And that's very much about this idea of interconnectedness, making use of the data we can get from devices and sensors around us to make the world a better place. That's the nice version of it. If you're into your NSA paranoia and spying and so on, then I'm sure there's all kinds of other things that we could use that data for. But wouldn't it be nice if we could have a city where the parking sensors alerted us over mobile phones to availability of places to park? We could adapt to the fact that the pollution sensors were saying that there's really bad pollution today by maybe putting up the toll rates on roads or something like that. You can imagine all kinds of applications for this stuff. we've got billions of transistors around us now. We've got many, many processors around, and many of them are just low power, low cost. They're not, super fast Intel chips. They're simple, good enough chips in everything from our washing machines and our fridges to manage their daily cycles to road sensors, pollution sensors, and all kinds of other devices. And really, this is actually an Eclipse chart. The Eclipse Foundation looked at this space a little while ago, recognized that there was an increasing amount of space for software developers to get involved in there, and started to put together an M2M or a machine-to-machine working group and set of projects. So we're looking at an explosion of connected devices. This is actually a couple of years old, this chart. It doesn't have a scale on it, which doesn't really help us at all. But the idea is that there will be many more network devices around us by 2020. Every couple of years, another analyst firm publishes another massive study saying, we're going to have billions of devices just in our pocket. There'll be chips and there'll be sensors and it'll go crazy. So, this is a big space. Costs are coming down. Raspberry Pi is an extremely cheap little piece of computing hardware. Many of these things are becoming very available. Development's becoming increasingly easy, and that's something that organizations like Eclipse are focused on. And very importantly, many of the telcos are focused on this space as well. How can they make better use and increase the value of their network as infrastructure costs plummet? So they're investing heavily in this space. But fundamentally, this isn't just about devices, as Darragh said earlier. It's about people and it's about information. So MQTT then, what is this thing? Well, bit of a long history. I'm going to put some wordy slides in front of you now. I apologize for those, but there's some points I want to share. First of all, it's interesting to note that although this is just kind of people are becoming more aware of it, it's actually been around since 1999. So back in 1999, IBM was partnering with an industrial firm called Arcom, which no longer exists. They've now merged into another company called Eurotech. And they were looking at the problem of oil pipelines and monitoring pressure on oil pipelines, where you've got, say, a cellular or satellite network with very, very high latency on the connection. And if you applied some of the existing technologies to that space at the time, you were often getting kind of massive failures in the network because devices were trying to poll too often. So they were using these, they looked at this problem and they thought, well, they needed a protocol which was simple, was very, very good in a constrained environment like a Siberian oil field, very remote, limited network connectivity. So they actually came up with this telemetry transport protocol focused on that space. And then fast forward 12 years from there, and eventually MQTT gets contributed as a piece of technology to the Eclipse Foundation. Now that's some software, right? That's a bunch of software that IBM and Eurotech, who bought Arcom, decided to give to Eclipse. Software is not the same as protocols and standards. So another thing has happened, which is that early this year, the standard or the protocol has been submitted to OASIS for standardization. So it's in the process of going through standardization at OASIS at the moment. The working group is quite massive, large numbers of companies involved in that effort. So where is this thing being used and how useful is it? Well, I'm going to very briefly talk about a couple of examples to start off with before diving down into a little bit more about what it is and what it's used for. One of the examples is the ferries over to the Isle of Wight. If you've been over to the Isle of Wight, you may be familiar with them. But a few years ago, about 3 or 4 years ago, their availability system was pretty rubbish. So you would phone them up and get a message to say whether or not the ferries were running if the weather was bad. Unfortunately, the man that recorded the message didn't come in till kind of fairly late in the morning and didn't go home and went home early. So you're very likely to get outdated information. So Andy Stanford-Clark, the distinguished engineer at IBM who invented MQTT, lives on the Isle of Wight, and he had a had an itch to scratch. So he decided to actually look at all of the ferries in the Solent, which you can do because the data is open. There's a GIS data about their locations on the map. He drew geofences around the 2 ports on either side of the channel. And then he scraped that data and published it on MQTT, and then so that he knew when the ferries were going in or out of port. And then he had the ferries actually start to tweet. So he wired that up very simply to Twitter, to the Twitter API, and had the ferries then start to tweet about when they were coming into port, getting rid of the man in the middle with the telephone message that was often outdated. Andy's farmhouse is the picture up on the right-hand side there. Andy actually has made his home a living laboratory for this stuff. He's the co-inventor, and he's automated almost everything. He'll get a message to his phone when his gate opens and closes, who's phoning him on the landline. He's got all of his energy monitored, so he knows how much energy is being used. And he also happens to have a llama farm, and he knows where all the llamas are at any point in time because he can track them around. Progressing around then clockwise to Twiga. Twiga was a project, another IBM project actually, which started because of the Fukushima radiation disaster, nuclear disaster. And the idea there was that you could get portable Bluetooth-enabled Geiger counters and find out what the radiation was in whatever area you were in, and then that would use MQTT to publish that data to the world so that you could get real-time maps of what the radiation situation was like. And finally, on the bottom left is probably the most interesting one, and one of the ones that's caused the most excitement in the technology community, and probably given MQTT one of its biggest boosts to date, which is that a couple of years ago, actually just around the time that this donation to Eclipse was happening, Facebook very independently blogged about the fact that they had this messenger application, this protocol that they use, or this little inbuilt app they use to let people message one another. And they said, you know what, we've discovered this amazing protocol that was invented to talk to satellites, and it's very low bandwidth and brilliant. And we're going to use it. So they actually use MQTT. They started using it in Messenger about 2 years ago, and they've now extended it to using it for all notifications across their applications. So your phones, be they Android or iOS or whatever, if you've got the Facebook app, almost certainly are running MQTT clients on them today. And they actually wrote a really nice blog post about how they'd analyzed the network traffic and the battery life, battery usage using this protocol, because they don't want to annoy people by draining your battery all the time you've got the Facebook app there. So they're using a very, very low bandwidth protocol, very low power protocol. So I mentioned I was going to sort of spend this first section on MQTT as a whole. So let's talk about some of the principles. Well, it's publish and subscribe. So if you're into messaging at all, it doesn't do queuing, it doesn't do point-to-point, reliable transactional stuff. It's publish and subscribe only. So I have some data. I'm going to label it with a topic. It's about the fact that I'm talking in London right now. So the topic might be JAX/London/Andy/talk, and then I might publish the data as every sentence I speak. And anybody who's interested in everything at JAX could subscribe to the top-level JAX topic. Anybody who's interested in things that are happening in London could subscribe at the London level. Anybody who's interested just in me could subscribe just to my topic. And actually, that turns out to be highly useful for sensor applications, because very often, you don't particularly care where sensors are. Well, no, that's a bad example. You may not particularly care what make of sensors you're dealing with. You care about where they are and what the temperature is, right? That's probably all you care about. So you may not need to navigate that whole topic tree. And you don't need to keep checking back. It doesn't need to be a request-response thing. You just want to receive an ongoing feed of information. I mentioned the satellite case earlier with the Russian oil lines. Well, when you're dealing with a slow network, you just want to make the packets as small as possible. And by the way, those networks are probably pretty expensive to run. Back in the day, you weren't buying a fixed-price broadband connection. You were paying for your dial-up connection in your minutes, right? So we want to minimize the amount of data we're sending on the wire. We want to expect the fact that networks aren't reliable, especially wireless networks. Even today, I can sit on the train down to my home in Kingston, and I'll still go through several black holes where there's just no there's no cellular reception. So we want to be able to cope with slow networks, poor quality networks, the fact that the latency may be very high. And also make the assumption that our client devices or applications may be very, very low power and have limited capabilities, be that processing or memory. Of course, if I'm running on a mainframe or on something bigger, then provide as many good qualities of service as I can. So it's publish and subscribe. It's very, very simple, actually. We've only got 5 or 6 verbs in the API: connect, disconnect, publish, subscribe, and unsubscribe. That's as complicated as this thing gets. On the wire, we're not talking about kind of JMS-style messaging. We're not talking about extensible properties folders and things like that. We are keeping the header really, really small, just a couple of bytes, in fact. So the smallest possible packet would be 2 bytes, and that would just be one of the control messages without any data in the body. And by the way, we also don't care about the body. We're not going to say all messages passed over MQTT must be XML or JSON or some other format. It's just a byte array. We don't care what you put in there. A couple of other things. Because we assume that the network might not be reliable, but we also assume that we might be operating in environments where we need some level of reliability, or we need to know when something's gone away, we've got this kind of cool feature called last will and testament. So when a client starts up, it can say to the thing it's going to talk to, which I'll mention in the next slide, if you don't hear from me for a while, then assume that I've died and publish this other message on my behalf on another topic. So it's literally like giving your will to someone and saying, if you don't hear from me for the next 10 years, then assume I'm dead and give all my worldly possessions to someone else. And we can also roll forward, assume that things can roll forward. And equally, we can go away and come back. So we have durable subscriptions. I'm not quite sure why these 2 brokers have 10s on them. I've just noticed them as we're looking at the slides, but that wasn't intentional. That's just formatting problems. So core concepts here. There are 2. They are brokers and there are clients. Brokers are the servers, which are dealing with all the connections and passing the messages between clients. And the clients are the things that are sending or receiving the messages. There's a little bit of an extension to that. In fact, it's optional. It's not even officially currently part of the spec, which says that brokers can be clients to one another and they can bridge their topics together. So in fact, if I'm this guy over on the right-hand side on a laptop with an application, I could subscribe to a topic. And if these 2 brokers are actually bridged together in such a way that they're sharing their data, then I could receive publications from any of those guys on the left-hand side. But that is optional. So topics are /delimited trees. I've got a couple of examples here, and I've also got some examples on the right-hand side of some of the notation that's involved. So, for example, the second one down is the wildcard. That's the pound or hash sign. That's the universal wildcard. So if I'm interested in everything from topic / down the tree, then I would subscribe to the hash. If I just want to skip 1 or 2 levels of the tree, then I can use the plus notation as a wildcard. I've mentioned a few other things at the bottom here. I've told you about the last will and testament already. We also support a keep alive, so that we know that we want to continue being there and to check back and keep that connection open. And finally, when I talk about Internet of Things and I talk to journalists in particular, they go, oh my God, you're going to put your house online and then the authorities are going to come along and unplug you from the world and you'll all die and then people will hack your light bulbs and everything will go wrong and what's the security model? Well, putting aside that that's a really stupid notion that the journalists keep trying to trick me into saying, we do have some security. One of them is that good old-fashioned username and password. Not particularly sophisticated, but it's there. We also support encryption using SSL, but fundamentally, the protocol is deliberately simple. It's kind of like a Unix utility, right? We keep Unix utilities as simple as possible, good at doing one task, and then we can chain them together. So the MQTT protocol is deliberately simple. It's remained simple over 3.1 releases of the specification, over 13, 14 years. And if you really need to do things like encryption, then put that in your application and give me the data to send on your behalf. So one last thing then in terms of capabilities in the protocol before moving on a little bit, qualities of service. So we can either say, well, this data isn't that important, I'm just going to publish it, and I'm going to specify quality of service 0, so the client and the broker aren't going to do any retry for me at all. I can also say, well, this is kind of important data, so quality of service 1 actually sends the message once, and if it doesn't get any kind of acknowledgement from the broker, the client will then send it again with a duplicate flag set to say, by the way, you may have seen this before. And finally, we try to get close to the more enterprise-y, JMS-y qualities of service that you might expect with a handshake. So we publish to the broker says, I've got that publication. Then we say, OK, thanks very much. Can you send that for me? And the broker says, yes, I've done it. It's not completely the same as some of the stuff you get with something like ActiveMQ or RabbitMQ or WebSockets or whatever messaging flavor is your poison, but that's the idea there. So it's simple, it's lightweight, it's really, really nice, and lots of people are using it in all kinds of ways. So one of the things I normally bring to this kind of presentation is a little Arduino that I can pass around the audience, and you can put your hand over the light sensor, or you can measure the temperature in different places, and I can get little publications. So we've got it down onto an Arduino, which has got minimal amount of memory on these things. Very, very simple processors. And it runs on Android. We actually got it running on a Kindle, or a jailbroken Kindle at a recent hackathon. And people use it for things like power monitoring. That actually was my house some time ago, a very long time ago, actually. It's also been kind of taken to heart by the broader software community. So we've got clients in pretty much any language you can imagine, as well as Java, especially since I'm here at a Java conference. Recently, we've had a Clojure client actually contributed, which is really fantastic. So one last diversion before I actually get down to looking at some code and examples. Let's quickly talk about the difference between this and HTTP and why would we do this when every device that's around these days has an HTTP client on it? So why not just use HTTP and REST for all of these interactions? Well, actually, the problem domain is significantly different, and there's no reason why you can't use HTTP for some of these things. But if you start to think about some of the differences, hopefully things become a bit more clear. First of all, HTTP was essentially invented for getting documents into a web browser. Okay? And we've bent it and we've turned it around and we've done weird things to HTTP over the course of the last 20 years to make it be much more of a universal transport for APIs for us. But fundamentally, it's still a request response, give me some text in a browser. It deals with documents. It deals with full-form documents, ideally. MQTT doesn't care. It just says, give me some data, I'll send it. That's it. It doesn't matter whether that's a full-form document. It can just be a simple drip feed that says 24.1, 24.2, 24.0, over and over again on whatever schedule you choose. This is a bit of an arguable one. I mean, HTTP is very, very well understood these days, and actually there's so many libraries for it that it's just wrapped up, so you often really never see it. But if you actually look at it, it's a really rich protocol. There's loads of things in there. There's lots of different commands. Post, put, get, delete are just a very limited number of them. MQTT, as I've shown you, has those 5 methods and is really, really trivial. I'll show you some code in a moment to show you how simple it is in Java. It's really lightweight, so I've mentioned that little 2-byte packet that's our smallest possible size. Optimized from the start for these kind of things. Whereas HTTP, if you actually were to use it for regular updates of data, you're putting a load of textual headers on the front, then you're sending your data. Distribution, so in order to do kind of one-to-many with HTTP, you're still going to go to a single point, and that point's going to have to call lots of other points, right? MQTT is distributing things for you. And now I appear to have the same slide twice, so there we go, that's better. We're really, really small, so the broker component itself can be compiled down to less than 80K, actually. IBM's reference version that they ship as a binary, they haven't open sourced it yet, is about 80 kilobytes. That's a C broker. The libraries, the client libraries themselves, as I mentioned, can get down to something as small as an Arduino. And HTTP often pulls in all this other stuff, like XML libraries that you may need to do whatever processing you're doing. And then finally, that quality of service point I made, because HTTP has none. There is no retry in HTTP. If you get a timeout, you're going to retry it yourself, right? There's nothing built in. Whereas with MQTT, we can do some of this stuff in the library for you. So home hackers absolutely love this stuff. Really, the primary community that's been growing a lot of these software implementations over the last few years have been people who have been picking up things like the Raspberry Pi and Arduino and mobile phones as they grow in capability and hooking them up and doing cool things. So when I was at IBM, one of my mentees, it's a really weird blog post, go read it, but he basically, for some reason, ended up with a mini, as in a car, full of rubber ducks. I don't want to know anything about the party that came from, but he decided to hook them all up as some kind of set of indicator lights and power them by, run them by MQTT. We've also, in the IBM lab, they also infamously had the Christmas lights that you could tweet the color to, and that it would drive an Arduino to change the color. So, okay, brokers then. Kind of key component. I've mentioned that we've got clients and we've got brokers, and the brokers are kind of the core here. Well, here are two, and these are not all of them, but they are both open source. I'm not mentioning in this particular case closed source ones and commercial ones from large companies like IBM who want to charge you lots of money for them. Both of these, as you'll notice, are not in Java. So there's a really, really great one called Mosquito, which is written in C. It compiles down very, very small. It pretty much, it does cover all of the MQTT standard and extensions like bridging. And if you've got Linux or a Mac, really, really easy to install and get started, and I'll show you in a moment. There's another product which you may have heard of called RabbitMQ, but that's a big enterprise broker. It's like ActiveMQ as well, actually, and that is Java, but I'll come back to that. I'm going to mention it in more length. It's more about the AMQP and the enterprise qualities of service, and over time it's evolved to recognize that in order to deal with these smaller devices and these other operating environments, it needs to evolve. So it's added support for MQTT, it's also added support for Stomp and HTTP. But even though I work for the company that sponsors it, I'm obliged to point out to you as MQTT people that it doesn't actually 100% cover all of the MQTT spec. So for example, today, it doesn't cover quality of service 2. But also dead easy to install. So let's actually just have a quick look. And I need to remember to mirror my screen, don't I? I remember now. I didn't do that earlier. And people pointed out to me that they were staring at a blank screen. Arrangement, mirror displays. There we go. Move you over there. Click over there. So this is not super exciting to demonstrate, to be honest. You're going to see some bits of data, and I'm going to type some stuff. I haven't got any devices to kind of light up and flash and do things. But take it for granted in some respects, if you would, that some cool stuff is possible here. So first of all, let's look at this broker. So I have a broker called Mosquito installed on my machine, and I can start it just by typing Mosquito. And yes, I absolutely do want you to accept incoming connections, otherwise you're going to be rather useless. Come on. You were playing nicely with me earlier. Thank you. So we now have a broker running. And what I can do is I can switch to another tab. And I can subscribe to that broker. Localhost. And let's subscribe to a topic called Andy. And sit and start listening. And obviously over here, we see that we've got a connection. New client is connected with a particular client ID. And the client IDs need to be unique. In another tab, let's do mosquito_pub. So we're going to publish some data. We need to give it the topic, which was Andy, Andy. And then we need to give it a message, which is hello world, with an extra W. And sure enough, brilliantly, that just worked. So we've got a message come through. Now, obviously, that's trivially simple example, and that's all using code written in C, so not particularly exciting to you here. What we also have, though, is a broker at the Eclipse Foundation called MQTT, m2m.eclipse.org. And I have a bridge connected to that, which actually will list out all the topics that are currently in use. So this is a public broker. Anybody can publish to it. This is a very, very long list of topics, and I'm not proposing to scroll all the way through it. But for example, you know, somebody's obviously been playing around with some home automation here with their kitchen bulbs. Bizarrely, somebody decided to just publish on lots and lots of topics with massive long UIDs, which I don't understand. So I'm going to scroll straight past those when I can eventually get through the list. Wow, I forgot hexadecimal. Brilliant. Nearly there. Here we go. So we've got some other things here. So these three topics here, GitHub / so there's the GitHub Paho repository. So we actually have a GitHub hook, so that every time something gets committed on one of these Paho projects on GitHub, then the commit gets published on this topic. So in theory, oh, that's awkward. You've just crashed, haven't you? My server-side bridge app has just crashed. Should I wait for you to come back? OK, well, again, take it as read. In fact, let me just go to subscribe to the topic over here. And instead of subscribing to localhost, let me subscribe to m2m.eclipse.org. And we get the last commit message from that particular project. So that's also kind of not particularly exciting. But one of the interesting, another interesting test broker out there on the internet has all of the national power grid usage, including, for example, the amounts of power that are being generated from coal, nuclear, solar, et cetera, and the current costs of those things and the different mixes of those things. So that you get some kind of interesting data off of some of these brokers. And that's just being streamed, obviously. Let's switch back to what I wanted to talk about. That was just giving you a really, really quick demo with some C stuff. Basic demo not using Java. OK, so there we go, just about halfway through. And that was just the intro to the protocol, Internet of Things, got us off the ground. Let's talk about Java instead, because that's what we're here for. Now, the interesting thing is that up until about 2 years ago, the Java landscape was more or less IBM, and that was it. And in fact, the Eclipse Paho Clients, the project that I'm the co-lead for, contains a number of pieces of code, three of which, I beg your pardon, are directly donated by IBM, who've been developing them for 10 years. So we have a C client, and we have a Java client, and we now have a JavaScript client as well that runs in the browser. I'll come back to that in a moment. But beyond that, we also have stuff from the community in there as well. So we have a Lua client, and I'll talk about why we have a Lua client in a moment. And we also have a Python client as well, which came from the Mosquito project. In the meantime, other organizations decided that they were either fed up with the Paho client or just had a better idea. So FuseSource have got their own as well. So those are now both available from Maven repositories if you're building code in Java, dead easy to pull in. Let's have a look at what some of the Paho code looks like. Is that OK for people to read just about? Although you gentlemen at the back may struggle, you're OK, good. So starting off, this is just the connect piece. So we set up an MQTT connect options object. So we can do things like, for example, in this case, we do something called set clean session. Clean session is all about that durable subscribers I mentioned. So clean session means I'm brand new, and even if you saw me before, give me a new connection, please. Don't give me any data that I might have that might have been left over from before. This is actually a chunk from one of the Paho samples. So there's some stuff in here which isn't relevant, such as the password and username. Obviously, if that was passed in from outside the program, we could set that on the connection. And then we construct an MQTT client object. In this case, as it's highlighted, this is a blocking mode client. So the Paho Java client codebase has an asynchronous callback client, and it also has a blocking client. And that's it. So that's setting up the basics here. We also obviously need to pass in the broker we want to connect to, and 1883 is the IANA standard port for MQTT brokers. We need to specify a client ID, which needs to be unique as well. So we're connected. What we want to do next, probably, before we send any data, we might want to wait and see if any data is available or coming into us. So we simply pick up that client object and do the connect, passing in any connection options. Then we subscribe. Really simple again. It's just literally subscribe to a topic with specifying a quality of service that we're happy to subscribe at. And then we just sit there waiting. And if anything comes in, we're going to print it out at some point, but not in this piece of code. Finally, then, the publish side of the story, slightly more to it, but not much, because we need to create an MQTT message. The message contains the payload, which is, in this case, just potentially just going to be text. And we're just going to send, in fact, a timestamp in this one. And again, we've presumably passed in the topic name from outside this code block. And then we just connect. That's it. Trivially simple. So I've mentioned Eclipse a couple of times. Well, actually, inside the agenda books you've got, on the other side of the agenda book is a small version of JAX magazine. And one of the features in there, actually it's about 6 months old now, talks about the Eclipse M2M universe. So the Eclipse Foundation building out this machine-to-machine kind of group of projects. So why is Eclipse in this space? Well, they really want to ensure that, as I spoke about clouds earlier, that this is not a lock-in environment, that you're not subject to the whims of 1 or 2 hardware vendors who decide on some protocols and force you to use them at great licensing cost. So what they want to do is they want to build up, for the Internet of Things in the machine-to-machine space, a set of protocols. We think we've got them. We've got MQTT. We've got a couple of others, OMRDM, and we have an Eclipse SCADA project as well now. Frameworks and runtimes. So in this case, we have a project called Kaneki, which is a framework for building applications, and Mahini. And also development tools. So actually, Kaneki comes with some Lua development tools. So those tools have actually been contributed from a company called Sierra Wireless. And Lua is an interesting language for this space as well, because Lua will compile down to a C binary and will run very nicely on embedded systems. So in particular, from an MQTT perspective, we're obviously in the communication protocol space, and I need to extend this chart to talk about Eclipse SCADA as well. But since this diagram and that article was published, back then we had 3 projects, and we were focused on the Raspberry Pi and Arduino as development platforms for some of these things. But since then, we've actually gained a whole bunch of new ones. So Mosquito is actually coming into the Eclipse Foundation as a broker, even though it's written in C. We have another project called Eclipse Ponte, which is Italian for bridge, and that is aiming to be a REST bridge between different protocols. So MQTT being one of them, and some of the other protocols that are around as well. We actually have 2 OSGI micro runtimes. One is called Cura, and one is called Concierge, that are going to be joining the Eclipse runtime project, designed to run on very small devices again. And then also the Eclipse Smart Home project. So there's been a project called OpenHAB that's been around for a while now, and they're contributing that to Eclipse as the Eclipse Smart Home project, looking to consume many of these other technologies like MQTT. So lots of activity in this space, particularly at Eclipse. Step back again onto the broader Java landscape. Well, what do we have? Well, at Eclipse, we have Mosquito, and that is the broker that you connect to if you connect to m2m.eclipse.org. Actually, that's a website as well, so if you go to m2m.eclipse.org, you'll find like a hub into all of these projects. But if you just use that URL from a TCP connection perspective, you'll get a connection to an Eclipse, a Mosquito broker. But there are 3 Java brokers. And again, if I'd been standing here 2 years ago, I would have said, no, there are no brokers in Java. One of them is called Maquette, which is recently moved to using Netty. I don't think it's particularly protocol complete, and it's on Google Code, so go have a poke at it. It's pretty small, pretty simple. Interesting, it's written in Java, you can have a play with it. ActiveMQ have been actually improving their MQTT support for the last few releases, so it's looking really, really nice now. And that gives you, as it does in RabbitMQ, the ability to bridge between protocols. So let's say you've got a JMS application running on top of ActiveMQ, then you can publish your messages and potentially have them go out as MQTT messages to smaller devices. And finally, the one I want to talk about a little bit more, and I'll do my next demos with, is this one called HiveMQ, which is not open source. I said I would mention some non-open source things, and that one is not. But it's very, very nice. It's 100% Java. It's come out of a company in Germany who will sell it to you. But a couple of really nice features. One of them is that it has a plugin system. So you can actually install additional security protocols. You can have additional logging functionality and so on, all delivered as plugins. It's pretty small. It's standalone. It doesn't do anything else. Like Apache ActiveMQ does all these other protocols. HiveMQ is just an MQTT broker, very standards compliant as well. And also, interestingly, supports WebSockets. So when we're talking about the Internet of Things, and also more broadly on the Internet, the web, right? The web standards bodies have come out with this idea of WebSockets, which are just essentially a persistent socket you can open from a browser and have data pushed at you. Well, that's more or less what MQTT does in a different context. So they work in many ways in parallel. They're kind of parallel lives, but actually they can be joined up really well as well. So we've got a number of brokers now, including the IBM's commercial one, but Mosquito and HiveMQ actually support the ability to proxy or tunnel, essentially, MQTT over WebSockets. So you can start to have an MQTT publisher and then have that delivered down to a web client. So the Eclipse Paho JavaScript client that we have actually supports that protocol and works well with all of these brokers. So you can have running in your web browser an MQTT client that's receiving a stream of data. That could be stock trades, it could be temperature information, anything you like. Some more tools from the Java landscape. Well, this one's actually been around for quite a while from IBM, but it was closed source, and now they've actually released the source to the Eclipse project. This is just a really simple tool that I'll show you in a minute. And you'll see how ugly and old looking it is. This was literally written about 10 years ago in some really naff old JVM. But it still works. It does the job. It's been ported over to the latest version of the Paho client, and it just lets you do simple testing, publish and subscribe. But more broadly, when we talk about Eclipse, we're interested in building an ecosystem, and we're building tooling, enabling people to develop Internet of Things software applications much more easily. So we have the Lua support in the IDE, and we also have a tooling plugin which lets you do similarly to what that GUI plugin, that GUI tool I've just shown you, but within the Eclipse IDE. So it supports all of the parameters you might want, including things like registering a last will and testament message for when you connect to a broker, and it's really, really handy for testing your applications. Stepping outside of the Eclipse world for a moment, I work for Pivotal, and Pivotal looks after the Spring Framework. And one of the really cool things in the Spring Framework, or one of the side projects, is something called Spring Shell. And Spring Shell is essentially an extensible framework for building your own command line shell utilities. So one of my colleagues has forked this and created MQTT Shell. And I'll show you this in a moment. But essentially, it gives you, as you can see from the help here, the ability to start doing things like connecting to brokers, subscribing, publishing, and so on from inside this little tool. So it's a nice little piece of Spring code. And I've mentioned already the Clojure support. That's literally only about two or 3 months old. I personally struggle a little bit with Clojure. I went along to Neil's talk about it yesterday morning, and he tried to persuade me that just by moving the brackets to the left of the calls, it was all fine and it would make sense, but it's still doing my head in. But anyway, we have a Clojure client, and we have a new Internet of Things company starting up in London who are working with the Clojure client and building up a sensor network or an open data project picking up sensor data from around London, which is kind of cool. Going back to that discussion I mentioned earlier about Facebook and low power usage, well, one of the guys who was at IBM, he's left now, decided that, well, if Facebook is saying that this is true, then maybe we should check whether it's true. We may say, well, it's less power to sit there with an open connection and have tiny bits of data pushed down to us than it would be if we sat there as an Android app on a phone and polled back within the same keep-alive interval and did that request response. So Steve Nicholas actually blogged about this, and he's done some really nice research to say, well, is this true? Is it lower power? And in fact, it is significantly lower power to sit there. So it's really, really nice for apps on platforms like Android. There are a couple of Objective-C libraries if you want to run it on iOS as well. But I imagine that most people in this audience are not so interested in that. One of the kind of cool little apps that's out there at the moment is a bunch of guys decided that since Google took Latitude away and wanted everybody to use Google Plus and stuff instead, they would re-implement Google Latitude using MQTT. So there's a mobile app you can get from them. I think it's in the Play Store as well. It's not in the iOS App Store, but you can build it yourself, which is a kind of little reference app to show you how you can use MQTT in that kind of context. It broadcasts your location. You choose the broker that it's broadcasting it on. I installed it for a while and then realized it really was broadcasting my location all the time on one of the public brokers that I'd hooked it up to and thought, not so keen. Anyway, it's kind of fun. And again, coming back to Spring, it's called MQTT-tude, as it says on the slide. MQTT-tude, yeah. It's a nice little demonstrator. And finally, again, the obligatory mention of my employer's favorite framework. We also have support for MQTT in the Spring integration toolset now. So let me switch back to showing you some stuff again, because I didn't bring my gadgets with me, which was very, very remiss of me, and I will chastise myself heavily and ensure that I do in any future occasion. Mirror displays. All these people will be even more bored than they will be by looking at the text I'm going to show them. So first of all, let's kill off our mosquito broker, because we don't need that. And in the meantime, let's start up HiveMQ, which is an alternative broker. And HiveMQ is now running. Now, and it's actually starting up some plugins as well, which I've set up. I haven't enabled the WebSockets plugin on this particular HiveMQ instance, so this is just going to sit there. All I'm saying is, look, hey, it's running in Java. It's a Java broker running on my laptop. And as I did before, I can do exactly the same little publish and subscribe setup. Where was my subscription client before? It'll be here, won't it? Ah, there we go. So we know that we've been subscribed to. In fact, the reason that's logging is because I installed that access log plugin. Previously, it wouldn't have actually logged that. And then publish again, and hopefully that will work. There we go. Brilliant. Amazing. In the meantime, oh no, actually I need to be in this directory here. Here's our ugly MQTT GUI, but we can connect to our local broker. Again, subscribe, and then go back and publish. And this guy's decided that we've got a new client, which indeed it has, subscription from client MQTT utility. And magically, Hello World appears over here. So really, really basic demos today, because I can't find my Arduinos. As I say, normally what I would do is I have an Arduino with a Wi-Fi shield that I put on the same network as my laptop and pass it around the audience, and then we'd get live streams of temperature and light and stuff coming in over MQTT directly. but I didn't bring that with me, so you'll have to imagine that one, I'm afraid. Apologies. There are actually, if you're using a Mac, there is actually an MQTT client app in the App Store as well, which is kind of in the Mac App Store. But I'm excited by the fact that we've actually got this innovation and this number of people now building stuff in Java with MQTT, and actually to the point of building brokers and putting them out there. So I'm going to finish off with a call to action as I did in my earlier presentation, which is really, try this stuff out if you're interested. It's lightweight, it's simple, it's small. It's really straightforward to get involved. If you find that our code is broken or we're not making enough sense to you, then we have a Bugzilla. Please go and attack us. We have a website called MQTT.org as well, which is a community site. It's not owned by any company. It's pretty lightweight in terms of the news and stuff that we publish on the blog there, but we have a wiki where people who are discovering little wrinkles in the specification or new ways of using this stuff, or they just want to share the cool projects they've done, do so. One of the coolest, I was asked when I was doing my interview with the JAX guys what the coolest use of MQTT I'd seen was, and I think that's pretty hard to nail down. There's lots of really fun ones. There are people that are using it to run their irrigation systems for their gardens, for example. But probably the craziest one that I've seen so far, beyond that one with the weird rubber ducks, was a couple of years ago. Have you heard of, if you're in the UK, have you heard of the TV show Bang Goes the Theory? It's kind of the modern Tomorrow's World replacement that they put on each year. And they decided they wanted to use those gaming headsets that are supposed to be mind-reading and drive to taxis with them. But rather than actually put the presenters into the taxis, they took the taxis down to the IBM lab where they kitted them out with some servos driven by Arduinos that pushed the accelerator and moved the steering wheel. So they had these guys sat in a lab with these headsets on, and then they were driving these two taxis down a racetrack using MQTT for the communication. Kind of seems to me to be one of those because we can type solutions to a problem, but it was kind of fun. And it got us on TV as well, which was great fun. OK, I'm finishing off a little bit early. Does anybody have any questions? All right, thank you very much for your attention. Thank you for attending JAX London. I've had a good time. I hope you have. And I believe this concludes our day. So thank you.